Hello and Assalamualaikum. We are from CEEC 1104A1. We are from Group 7. We will present a video about our mini group project ECG263 Soil Engineering Laboratory.
Before getting started, let's introduce ourselves first. My name is Muhammad Haziq Hanan bin Sapili.
My name is Muhammad Amar Daniel bin Farid Irman.
My name is Muhammad Hanif Darwish bin Kamaruzaman.
So this is the video outline, which is introduction, background study, methodology, finding, discussion, conclusion, and lastly cost contribute.
Let's start with introduction. Soil is an important material in civil engineering because it supports building road and bridge. With soil has low strength and may cause settlement and crack. This project uses 10% eggshell powder as a recycled material to improve soil properties. Eggshell powder contains calcium carbonate, which can increase soil strength. Two tests are conducted: alternate limit test, standard proto test. The result of untreated soil and treated soil will compare. This project also supports sustainable construction by reducing waste and promoting SGD4 and SGD9 of natural aggregate with sustainable material while maintaining the standard brick dimension.
The first part of background study is attribute limit. Determine the moisture content where soil change its state. Measure the liquid limit and plastic limit. Liquid limit is the moisture content when soil change from plastic to liquid state. Plastic limit is the moisture content when soil change from semi-solid to plastic state. Calculate the plasticity index using Pi equal to LL tolak PL. Pi is used to classify the soil. Evaluate soil engineering properties such as plasticity, shrinkage, and shear strength. Second part of background study is standard proto method. Determine the compaction characteristic of the soil. Compact the soil using a standard mold and rammer. Prepare soil sample with different water content. Plot the compaction curve. Determine the maximum dry density. Determine the optimum moisture content. MDD is the highest dry density of the soil. OMC is the water content needed to achieve MDD. Improve soil compaction during construction. Increase soil strength. Reduce settlement. Improve structural stability. Commonly used for road drains and foundation. Help engineers produce a suitable design. Last part of background study is use of eggshell powder in soil. Use eggshell powder as a recycled material. Improve the engineering properties of its soil. Contain a high amount of calcium carbonate. Increase soil strength and stability. Improve the bond between soil particles. Reduce the plasticity index. Reduce shrinkage and swelling. Increase the maximum dry density. Lower the optimum moisture content. Allow better compaction with less water. Improve the strength of the soil. Make the soil more suitable for construction. Provide an environmentally friendly method for soil stabilization. Let's move on to our next part of this video, which is methodology. The first part of methodology is preparation. First, I will talk about soil preparation. Soil collected near the forest behind the academic building. Dug using a hoe and a bucket. Dried in an oven to remove moisture. Sieve using a 0.425mm sieve. Soil is ready for testing. Next is eggshell powder preparation. Each member collected at least 10 used eggshells. Eggshells were crushed using a hammer. Total eggshell powder prepared was 500 grams. Store properly in the laboratory. Next part of the methodology is apparatus. First, I will talk about liquid limit cone penetration test apparatus. Cone penetrometer apparatus, top wash or timer, cylinder cup, 0.425mm sieve, glass plate, spatula, straight edge, moisture cans, wash bottle containing distilled water, weighing balance, drying oven, soil sample, eggshell powder, treated soil. Next is plastic limit test apparatus. Moisture cans, glass plate, drying oven 105°C, weighing balance, wash bottle containing distilled water, soil sample, spatula, 0.425mm sieve, eggshell powder, treated soil. And the last part is standard proto method apparatus. Standard proto mold 1000 ml, rammer 2.5 kg 300mm drop height, proctor's needle 20mm and 37.5mm sieve, mixing equipment, steel straight edge, balance, airtight container, measuring cylinder, sample extruder, eggshell powder, treated soil.
This is the procedure for untreated cone penetration test. First, prepare 300 gram of soil sample. Next, add distilled water and mix well. Third, fill the cylinder cup. After that, perform cone penetration test. Then, record penetration reading. Next, take moisture content sample. And lastly, repeat the test for other sample tests. For treated cone penetration test, first, prepare 300 gram of soil sample. Next, add 30 gram eggshell powder, which is 10% of the mass of soil. Thirdly, add distilled water and mix well. After that, fill the cylinder cup and then perform cone penetration test. Next, record penetration reading and take moisture content sample. Lastly, repeat all the tests for other sample. Next, we go to untreated plastic limit test. First, we should weight moisture cans. Secondly, add distilled water. Third, roll soil into 3 mm thread. Then, collect crumble soil. After that, dry in oven. And lastly, repeat the procedure for other sample tests. For treated plastic limit test, first, weight moisture cans. Second, add 30 gram of eggshell powder. Third, add distilled water. After that, roll soil into 3 mm thread. And then, collect crumble soil and then dry in oven. Lastly, repeat all the tests for other sample. Lastly, we go to standard proctor method for untreated soil. First, we should prepare 3 kg of soil sample and then add water of 210 milliliter. After that, fill mold in 3 layers and then compact each layer with 27 blows. Next, measure density and moisture content. And lastly, repeat with different water content. For treated soil, first, prepare 3 kg of soil sample. Second, add 300 gram of eggshell powder, which is 10% of the total mass of soil sample. And then add water. After that, fill mold in 3 layers. Next, compact each layer with 27 blows. And then, measure density and moisture content. Lastly, repeat all this procedure with different water content. This is the graph of untreated cone penetration test. The moisture content value obtained is 25.63%, 27.45%, and 27.94%. For penetration, the value is 11.0 mm, 13.5 mm, and 16.0 mm. From the graph, the liquid limit value is 42%. This is the graph of treated cone penetration test. The moisture content of value obtained is 25.22%, 27.92%, and 29%. For penetration, the value is 10.0 mm, 13.0 mm, and 13.8 mm. After plotting by using this information, the liquid limit value obtained also 42%. After that, we go to plastic limit test. This is the plasticity chart for untreated plastic limit test. From the graph, we know that the soil is clay of intermediate plasticity. For treated plastic limit test, the plasticity index value is 19.73%. By plotting this information on the graph, we know that the soil is clay of intermediate plasticity. Next, we go to untreated standard proctor test. From the table, The value for moisture content is 7.23%, 10.26%, 13.12%, 17.95%, and 20.82%. For dry density, all the value is in gram per centimeter cube unit. The value is 1.26, 1.27, 1.35, 1.42, and 1.33. After plotting the graph, we know that the maximum dry density is 1.42 gram per centimeter cube and optimum water content is 17.80%. Lastly, we go to treated standard proctor test. From the graph, the value of maximum dry density is also 1.42 gram per centimeter cube and optimum water content is 26.50%.
For our discussion, liquid limit, the value of untreated soil, liquid limit is 42%. Treated soil, liquid limit is 42%. Both soil have the same liquid limit, but treated soil required slightly more moisture to reach the same penetration. For the plastic limit, untreated soil, plastic limit is 90.55% and plastic index is 22.45%. Treated soil, plastic limit is 24.27% and plastic index is 17.73%. Treated soil became less plastic, more stable and less sensitive to water. For standard proctor test, untreated soil maximum dry density is 1.42 and optimum moisture content is 70.80%. Treated soil maximum dry density is 1.42 and the optimum moisture content is 46.50%. Treated soil require more water because eggshell powder absorb additional moisture. For precaution, we need to clean the cone before every penetration test. Roll the soil thread to about 3 mm during the plastic limit test. Compact its soil layer uniformly using the correct number of blow and rammer height. Next, our conclusion. The project successfully evaluate the effect of 10% eggshell powder on soil properties. Eggshell powder increase the plastic limit and reduce the plasticity index. Liquid limit and maximum dry density remain unchanged. Treat soil require higher optimum moisture content because eggshell powder absorb more water. Overall, eggshell powder improves soil stability and can be used as a sustainable soil stabilizer. There are a few recommendations such as clean the cone before every penetration test, make the soil sample thoroughly before testing, repeat the plastic limit test and use the average result, measure the moisture content immediately after the proctor test to reduce water loss. Lastly, cost contribution. First, improve soil engineering knowledge. This project helps students to understand soil stabilization using eggshell powder through laboratory testing. Second, support sustainable construction. Using waste eggshell reduce environmental waste and promote sustainable engineering practice. The third one is improve practical laboratory skill. Students gain hands-on experience in conducting the ultraviolet limit test and standard proctor test. For the last one is improve data analysis and problem solving. Students learn to compare untreated and treated soil, interpret the test result to evaluate soil performance.